Okay, guys. We left off talking about vertical and horizontal asymptotes, right? With vertical and horizontal asymptotes, we talked about our rules yesterday, right? Vertical asymptotes, we set the denominator equal to 0. As long as that factor doesn't cancel, it's a vertical asymptote as opposed to a whole. Horizontal asymptotes, it has to do with where is your larger power. Bottom, top, or are they the same? And then follow the rules there. So this example asks us to determine any horizontal or vertical asymptotes of this graph. Thoughts?
It has a horizontal asymptote of y equals 0.
Yes? No? Is that where you're going, Autumn?
Yeah. Well, I was just say set the denominator equal to 0.
You were going to go the vertical direction. Okay. And it doesn't really matter which direction we go, right? Both have to be done. So let's talk about the horizontal real quick. Okay. Horizontal, you look for the bigger power, yes? And when we talk about looking for the bigger power, what's the biggest power on top? The only power on top, x to the first. What's the biggest power on bottom? X to the second. Those are the only two terms that matter when you're trying to find horizontal asymptotes. Okay, that's all that matters. And so at that point, then we can notice that, okay, x to the second is on bottom. Since bigger power is on bottom, then we are going to state our horizontal asymptote as y equals 0. Okay? Let's talk vertical. With vertical in mind. I heard set the denominator equal to 0, right? I think it was Autumn that said that. So we're going to take x squared minus x minus 2, set it equal to 0. What do we have to do?
Factor.
Yeah, we're going to hope it factors, aren't we? So we're going to factor this. And more likely than not, it will. X squared is x and x. What about my numbers?
-2.
Multiplying to be -2, adding to be -1 is a -2, +1 combo. And so what's that tell me?
X equals 2.
Yeah. If we officially set each part equal to 0, x minus 2 equals 0, x plus 1 equals 0, we're going to have a vertical asymptote at x equals 2, and we're going to have a vertical asymptote at x equals -1, correct? Okay. Now, that's all it asks us to do, and that's all officially we have to do. But I want us to look at the graph here. And I'm going to talk about sketching it out by hand, and then we'll check it on the calculator. Okay? Because I want to show you what you know. I want to show you guys what you know here. So, what we know right now is that we have a horizontal asymptote at y equals 0, right? Y equals 0 being the x-axis. So we have a horizontal asymptote right there. We have vertical asymptotes at 2 and at -1. Now, without even looking at our calculators, and some of you may have already looked, but without looking at the calculators, we know this graph is going to be in pieces, isn't it? Okay? I've got 2 vertical asymptotes here, so I could very well, and I will have 3 pieces of graph, because our graph is not going to cross over a vertical asymptote. Okay? Now, I'm going to kind of take you through the graph. And, given more knowledge, you guys could graph this by hand too. But because my fraction is a positive fraction, I know that when I start, I'm going to start on my right side of my graph, and I'm going to start on the positive side of the x-axis. Okay? Because I have a horizontal asymptote, what that means is as my graph goes off to the right, it's going to run alongside. Okay, our horizontal asymptotes, we talked about them being in behavior, which is what I'm going to talk about next. And that's what my graph does as it runs off to the ends. Like, if I have a horizontal asymptote, my graph is going to run along that 0. It's not going to go up to infinity or down to negative infinity. It's going to run along. Okay? Now, in terms of going this way, well, as I continue this way, what's going to happen? I have a vertical asymptote here. Can I cross through that? No. So what your graph is going to do is it's going to kind of do a curve up then. Okay, and it's going to run up and along that vertical asymptote. As you learn more about graphs, you'll find out that at a vertical asymptote, your graph will typically change signs. So here my graph is positive and going up. On the other side of this vertical asymptote, my graph is going to be negative and going down. Okay, and again, no, I'm not expecting you to be able to do all this on your own. Okay, so don't stress, oh my gosh, I have to know that. Not yet, okay? This is stuff for down the road. Now, what we don't know here, and again, this changed signs because there was only one x minus 2 factor. Here, I don't have anything telling me that my graph goes upside down, and what I do know is that it actually is going to cross through the x-axis at 0. Okay, and so this graph here runs along, going up along that other asymptote. Now, I just crossed through a horizontal asymptote, didn't I? And here's the deal. Horizontal asymptotes determine end behavior. As you go off to positive and negative infinity, your graph will not cross the horizontal asymptote. Right here in the center, not at the end, your graph could possibly cross through a horizontal asymptote. It won't cross through a vertical asymptote, and it won't cross through horizontals at the end. But it can in the middle. So this is typical. Okay? And then the other thing, vertical asymptote, my graph is going to change signs again. So it's going down along that asymptote, and then we've got a horizontal asymptote to run along. So this time it's going to run below that. Okay? Now, with that in mind, did you graph it on the calculator? I haven't yet. I don't have my calculator. Did you get everything done? Okay, thank you. And then, if we think about it, show me your review worksheet during class or something, okay? Okay. Let's see, what is it? Have you graphed it and looked at it?
Yeah.
Yeah.
Looks just like
Hold on. Nope. Oops. I'll give you my C chart for third hour. Really don't should be turn on the elmo. Okay. Finally. Looks like similar to what we have up there, right? Now, here's what I'd like you guys to start to be able to do, okay? We've looked at things and we've talked about, like, okay, how to know what's going on there. Knowing, like, oh, hey, there's a break. There's probably a vertical asymptote there, isn't there? Okay, yes, you can do the idea of tracing to help figure that out, but what I also want you to realize is, without tracing, could I look at this and be like, oh, hey, factor my denominator and look at those pieces and say, okay, we've got the 2 and the negative 1 there, those type of things. Okay, the more we can put about these graphs, the more we can put together about these graphs, the better we'll understand what all is going on. Okay? Okay. Questions there? Okay, let's talk about end behavior then. And when we talk about end behavior, as I mentioned, we're pretty much going to be talking about horizontal asymptotes here. What's the graph doing at the end? End behavior is what is happening on the far left and far right of a graph. So when I say far left and far right, think it's what's happening at negative infinity and positive infinity of a graph. If there is a horizontal asymptote for the function, it will be approaching that number. Okay, so horizontal asymptotes are essentially in behavior. That's what the graph is doing at the end. It's approaching that horizontal asymptote. If the graph is going to infinity or negative infinity, then it will approach that value. And we'll talk about that probably with slant asymptotes. Okay. Now, the direction says determine the end behavior of the function. Notice what it said. If there is a horizontal asymptote for the function, it will be approaching that number. So when you're asked about end behavior, think about horizontal asymptote here. Okay. So what are your thoughts about y equals 3x over x squared plus 1?
Y equals 0.
Yes? No?
Yeah.
Y equals 0 because?
Biggest power is on bottom.
Okay, she looked at biggest power. So what matters here, on top is the 3x, on bottom is the x squared. And so looking at that biggest power on bottom, that will give me the indicator of y equals 0. And if you even went as far and canceled an x out, because I've seen some people do that where they'll start canceling x out, you still get 3 over x. And 3 over x still gives us bigger power on bottom, right? Okay. And yeah, what we can think about there is if you take 3 and you're dividing by a bigger and bigger and bigger number, that fraction is going to approach 0. So that's the y equals 0. What about b?
Y equals 3.
Yes? No? She says y equals 3. What do we have to point out here?
The coefficients.
Okay. My biggest power on top is 3x squared. My biggest power on bottom is x squared. These powers match, yes? Go back up to your rules from above. When the powers match, what are we using? The coefficients. So you can forget the x squareds and think 3 over 1, which is 3. Okay. And again, it says determine end behavior. You forgot to write up here. Think horizontal asymptote. Doesn't fully give you the answers, but it'll get you most of the way there. C.
No horizontal.
Okay. Do we agree no horizontal asymptote? Now, that's not the answer to my problem, though.
What?
Okay. Because is the question asking me what are the horizontal asymptotes? No. Okay, so I will agree, though, that on top, my biggest power is x to the third. On bottom, my biggest power is x to the second. Biggest power on top, I agree. It does indicate that there is no horizontal asymptote, but that's not my final answer. Because the question was not what is the horizontal asymptote, it's in behavior. What is the graph doing in terms of in behavior? So I talked about canceling some. What happens if we start simplifying this? As in right now I have 3x cubed over x squared. What can cancel out of top and bottom? X to the, how many x's can cancel out? 2, right? X to the second cancels. That means on top I still have 3x. On bottom I still have 1. Okay, well, right there, by canceling out that behavior, our asymptote is going to be y equals 3x. Okay? And think with me, what does the line y equals 3x look like? Has a slope of 3, a y-intercept of 0. So y-intercept of 0 goes through the center. Slope of 3? Up 3, right 1. So this slant asymptote is going to look something like that. Okay? So when we talk about in behavior, the idea is that my graph is going to follow the line y equals 3x. Now, let's look at this one. So first of all, let me graph what was our original equation. 3x to the third over x squared plus 1. Now, first of all, let's graph that. Okay. So that's what this equation looks like. There's definitely not a horizontal asymptote. That's pretty easy to see. However, if you look at the angle that graph is going, it does follow kind of a line there. And that line that it's following is y equals 3x. So we could talk about the fact that as our graph goes infinitely right, it's going infinitely up. As it goes infinitely left, it's going infinitely down. But it follows the line y equals 3x. And I can show that. Notice what the line y equals 3x just did when I graphed it. It goes right through the center of it, doesn't it? Okay? And if I, probably even if I zoom out, I'm just guessing here, but it's going to look like one line pretty much. Because you barely see the squiggle in the red there. And then the pink pretty much grew right over it. Okay? So, very much, that's my in behavior. It's following that one. Okay? So, you're giving that type of information when it asks for in behavior. Think horizontal asymptotes, but what's it have? Just don't tell me no horizontal asymptotes. Okay, your homework is page 93, 48 to 66 evens, and Katie says it's how many questions? 9.
Well, I counted.
She was counting. Is it 9?
I think it's 10.
I was thinking it was
Did I
10.
count wrong? 48.
Anyways, it's not a ton. That's what I know.
It is.
Oh, it's my one job.
I just saw you counting over there.